All right, let's take a look at part 2 of the Unit 4 review. On the homework assignment, I did see a lot of students get this wrong, the negation. So let's take a look at that. Write the negation and state the truth value of the, I can't remember what it said, the premise and the negation. So, to negate something, you just add or remove the word not. You don't try to correct the statement. If the statement was like, the Astros are a football team, you would not try to correct it by saying the Astros are a baseball team. You would say the Astros are not a football team. That's how you negate. Add or remove the word not. So, A, Alaska is not the largest state. Alaska is the largest state. So we do assign a truth value. This is false. Alaska is the largest state. And then the negation here, you don't need to write the word negation, but so you know what's happening. We remove the word not. Alaska is the largest state. And this statement is true. So, if it tells you to assign a truth value, look at what it wants the truth value on. In this case, both the original statement and the negation. Then we have J.J. Watt is a football player. That is true. The negation is J.J. Watt is not a football player. So again, adding or subtracting the word not. And this would be false. You don't need to overthink it and decide, well, since he's retired or whatever. We're not trying to trick you on these. So, let's keep going. 9, 10, and 11. So, make a truth table for the conjunction of P and Q. So it tells you that the conjunction is the and. So, this is how you should do your truth tables. You have a P, you have a Q, and in this case, we are looking at P and Q. So that's the symbol for and, that kind of horseshoe that goes facing up. So this is P and Q. So the P column always starts like this, or looks like this. True, true, false, false. And the Q column is always true, false, true, false. I'll zoom in. And the reason we do this is because now we will be able to consider every combination of true and false for premise P and premise Q. So we have a true for P, a true for Q, a true for P and F for Q, false for P, true for Q, and then both false. It's all combinations. And so if it's and, well then they both have to be true. So the only one that has a true conclusion here is the top. Again, it's P and Q must be true to have this truth value over here. A true P and a false Q, well, they're both not true, so this is false. For the third row here, again, they're not both true, so this is a false outcome. And finally, false, false, neither is true. So the conclusion is false. Again, so this is the conclusion, P and Q. The only way the conclusion can be true is if both P and Q are true. And this is something, you can just kind of memorize. Because it's always going to work out how you start your P and Q. It's going to be true, true, false, false. And then for Q, true, false, true, false. Again, this evaluates every combination of a true value for the P and a true or false value for the Q. And now we're looking at the disjunction of P or Q. So again, it tells you, and we know that the or symbol is the regular U shape. So P or Q. And this is what we're looking for on, to get credit for these questions. So now we only need one to be true. Only one needs to be true. Whereas above, both needed to be true. And that's because the word or. So this will, you'll see how it goes. A true value for P, a true value for Q, they're both true, and that's a true outcome. Again, only one of them needs to be true. A true value for P, a false value for Q, only one of them needs to be true to have a true outcome. Same thing right here. We have a true value for the Q. The only outcome that is false in the disjunction of P or Q is the final row, in which they are both false. Neither one is true, and that's our answer. Finally, make a truth table for the conditional of P and Q, of if P then Q, and that looks like this. That's the symbol. You need to know these symbols here. So we have our P, our Q. Again, it's going to go true, true, false, false, and true, false, true, false. And then we are looking at P, if P, then Q. And so I'll talk about this a little bit. If P is true, then and Q is true, that is a true outcome. An example I've used is something like, you could say to someone, if I give you $20, then you give me a ride or something. And think about it like from your perspective. You're giving the money, you receive a ride. So if I give you $20 and you give me a ride, that is a fair outcome. And just to talk a little bit about it, these truth tables are like the foundation of computer science. These binary truth values. So you have to assign a true or false value to each of these. So I give you $20, you give me a ride, that's a true outcome. What if I give you $20 and you do not give me a ride? Well, that's unfair. That is a false outcome, or think about it like an unfair outcome from my perspective. Now, this is the confusing one. We'll come back to the third one. But a false, I don't give you $20, you don't give me a ride. That's perfectly fair. So if P is false, then if P and Q are both false, so if P then Q has a true outcome. And then let's say I don't give you $20, but you give me a ride anyway. From my perspective, there's nothing wrong with that. So you can just accept that this is always the case. The if P then Q truth table comes out to true, false, true, true. And hopefully that explanation works a little bit. I'll move on. I used to use an example like you find a picture, or no, you find a purple elephant in the library or something. I found like a fun example, but students would try to like solve it as if it were a riddle. So it had to be more practical. Let's get into number 12. Use the symbols and state the truth value. A lot of you that submitted this assignment did not use the symbols. You got the truth value. But we need to see the symbols. So if you're using, or if you're going to do like a digital copy of the test, I don't know, use the little paint button or something. Make sure you have the symbols. So statement P is the Earth has one moon. Statement Q is Houston is the capital of Texas. So A is the Earth has one moon and Houston is the capital. So again, the Earth has one moon, that's our P statement. Houston is the capital, that's our Q statement. And so P, there's our symbol for and then Q. And then we have to think about our truth tables that we made on the previous problem. So Earth has one moon, that's true. Houston is the capital of Texas, that's false, because Austin, of course. And so what happens when we have a true and a false? Well, you can look at the truth table that we just made. This is a false truth value because it's an and statement, and we have a false value. So this is the truth table, actually put in place or put in use. Earth has one moon or Houston is the capital. So again, that's our P statement. This is our Q statement. So this is P or Q. You need to know your symbols. And Earth has one moon. That's true. Houston is the capital. That is still false. But this is an or statement, and you can look at the table. But a true or false, as long as one value is true in an or statement, then it's a true outcome. And then we change up the P and Q here. If you own a Cadillac, that's our P, then you own a vehicle, that's our Q. And we see the words if, then. So you need to know your if-then symbol, P, then Q. If P, then Q. And so, if you own a Cadillac, then you own a vehicle. But we can assume these are true. And this would have a true outcome, because this is a true statement. If you own a Cadillac, then you own a vehicle. Let's look at more statements. There's 15 questions. We'll finish this up. P is the statement, you own a bird. Q is the statement, you own a canary. Part A is they call this a tilde. It basically means not P. So we're negating the statement P. So when you see this, you need to negate. You do not own a bird. And then we know that this is the if-then. If Q, then P. You might get the order of these mixed up, because it's usually P then Q. But here it's telling us if Q, then P. And what would that look like as a statement? If, and then here's Q. You own a canary. And then this is the symbol that tells us that it's an if-then. And then we use our P statement. You own a bird. And this is that's a valid statement. If you own a canary, then you own a bird. So look at make sure you don't get these mixed up, the order of them. It tells you what P is, it tells you what Q is. You have to know that the arrow is your if-then symbol. So we build the statement using Q and P. Number 14, the statement is, if you live in Albuquerque, then you live in New Mexico. I'm going to abbreviate here, but on the test, if you need to, this takes up some room. If you need to write this on a separate page, that's perfectly fine. So if you live in Albuquerque, so you live in Albuquerque, that's our P. Then you live in New Mexico, that's our Q. Because that's the order it's kind of written here. So let's do the conditional statement. If P, then Q is what this means. If P, then Q. So if you live in Albuquerque, then you live in New Mexico. Albuquerque is the city in New Mexico, so that is true. Also, on one of the assignments you turned in, I mentioned that a lot of you missed the logically equivalent part, so we'll talk about that as we go. That's the conditional. The converse, I abbreviated these, is if Q, then P. If Q, then P. So let's build that statement. Q is the statement you live in New Mexico, so if you live in New Mexico, then you live in, and then our P statement is you live in Albuquerque. And of course that is false, because there are other cities in New Mexico. I can't think of any, but surely there are. The inverse is, again, that tilde means not. It's negating the statement P, and then again, negating the statement Q. So this is, if not P, then not Q. So this statement is, if you don't live in, and then again, go make sure you're getting your P's and Q's right. If you don't live in Albuquerque, then you don't live in New Mexico. So again, don't live in Albuquerque, that's not P. Don't live in New Mexico, that's not Q. And then the arrow tells us it's an if-then. And of course, again, this is false. If you don't live in Albuquerque, then you don't live in New Mexico. You could live in other cities that are not Albuquerque that are in New Mexico. And this is logically equivalent. We notice that the converse and inverse have the same truth value. The inside pieces have the same truth value. And as you'll see, the contrapositive will have the same truth value as the conditional. So the contrapositive is if not Q, then not P. So if you don't live in New Mexico, then you don't live in Albuquerque. And of course, that's true. Albuquerque is in New Mexico, so if we don't live in New Mexico, there's no way that we can live in Albuquerque. So the top and bottom, logically equivalent. The middle two, logically equivalent. Finally, hope you're still watching, because this is, students always miss this unless you watch the review. Because it says draw a Venn diagram. And we've looked at so many Venn diagrams that are like this. But remember, at the beginning of this unit, we learned about the kind of bullseye Venn diagram. And that's what we're looking for here. Draw a Venn diagram and state the validity. We'll talk about validity in a second. So the premise, one premise is all cats are mammals. Another premise is a calico is a cat. The conclusion is a calico is a mammal. You don't want to draw two overlapping circles, one mammal, one cat or something, because a cat is a mammal. So on the outside we have our group mammals. And then inside here is the group cats. And then a type of cat is a calico. And that's what the Venn diagram should look like. The bullseye Venn diagram with the types of cats, specifically in this case calico. And then the group cats is inside of the group mammals. So it's that bullseye Venn diagram. And so validity, it has to be sound and valid. And if it's sound, that means like the steps you took make sense. And in this case it does. All cats are mammals. A calico is a cat. So a calico is a mammal. That makes sense. Calico is inside the group cats, which is inside the group mammals. So this is valid because the conclusion is true and the steps we took to get there make sense. Is the easiest way to describe validity. And I believe that's it. So let me know if you have any questions. The test is due Sunday by 11:59 p.m.